Hello students, welcome back to the classroom point. In our today's class, we are going to discuss the valence bond theory. So we shall begin the class now. Valence bond theory, also known as the VBT, valence bond theory. So this valence bond theory, to know the valence bond theory, we must have the knowledge of the certain information, that is electronic configuration, atomic orbitals, overlapping of atomic orbitals, and hybridization. So we must have an idea about these four concepts to understand the valence bond theory in a clear way. Anyhow, all these concepts were discussed in our previous classes. If you don't watch those classes, please do watch and come back to this class. Why? Because this valence bond theory depends and it is proposed based on the quantum mechanical approach. So this quantum mechanical model involves so much of the higher mathematical calculations, but in today's class we are going to discuss the qualitative and non-mathematical approach of the valence bond theory by taking the hydrogen molecule. So let's begin the class with how the valence bond theory is applicable to the H2 molecule. So in H2 molecule, we know that there are two hydrogen atoms which are connected each other by a single bond. Let us give the two hydrogen atoms, first hydrogen atom as Ha and the second hydrogen atom as Hb. So when two hydrogen atoms are present separately, there shall be some electronic interactions will involve in both of these hydrogen atoms. Let us see what type of electronic interactions are present in these two hydrogen atoms. In these two hydrogen atoms, whenever they independently present, nucleus attracts only its electron. Example, if you take the hydrogen atom A, it has its own nucleus, that is nucleus of the first hydrogen atom, and its electron of the first hydrogen atom A. Similarly, when hydrogen atom B, if you are considering, it has its own nucleus and its electron. So independently when these atoms exist, the nucleus of hydrogen atom A will attract its own electron and the nucleus of hydrogen atom B will attract its own electron. So basically in independent hydrogen atoms, two attractive forces are present here. So let us write down the attractive forces. Attractive forces are nucleus of the A atom with its own electron as well as the nucleus of the B hydrogen atom with its own electron. But whenever these two hydrogen atoms are approaching each other, then obviously the nucleus of one hydrogen atom try to attract the nucleus of the electron of the another hydrogen atom. Similarly, the nucleus of the B hydrogen atom try to attract the electron of the A hydrogen atom. So that other type of attractive forces are Na can attract the Eb as well as the Nb can attract the Ea. So these attractive forces we can represent in such a manner that, so I am taking this is the Na and Nb, Ea and Eb. Initially the attractions are present between the Na and Ea and here Nb and Eb. But when the hydrogen atoms are approaching each other, the nucleus of one atom try to attract the electrons of the another atom, so that new type of attractive forces try to arise. And here also new type of attractive forces try to arise and weakening these attractive forces. So previous attractive forces try to weaken and new attractive forces starts emerging. At the same time, there shall be repulsive forces also. The repulsive forces are the electrons of one atom can repel the electrons of the another atom, and the nucleus of one atom can repel the nucleus of the another atom. So here we can write down that nucleus of the A atom repels the nucleus of the B atom, and similarly electron of A atom repels the electron of the B atom. So whenever hydrogen atoms are coming towards each other to form the H2 molecule, attractive forces as well as repulsive forces both starts operating. But practically it was proved that the attractive forces are dominating the repulsive forces, hence a H2 molecule is going to be formed. So here we can write down that attractive forces dominating the repulsive forces. So that H2 molecule is going to form. That we can see in the energy profile diagram. So let us take the energy on the y-axis and bond length, or simply we can write down it as a length on the x-axis. Imagine this is the highest energy that the hydrogen atoms possess when they are in the gaseous state or independently. So independently, when hydrogen atoms are present separately, they have the highest energy. When they come closer to each other, as we said, attractive forces start dominating than the repulsive forces. Whenever the attraction is developed between any two atoms, then obviously there shall be loss of some energy that gives stability to the molecule. That's why whenever you see these two, see the atoms are coming closer to each other. Atoms are coming closer to each other. From here to here, the distance between the atoms gradually decreases, and afterwards at a particular time, so they formed completely overlapping of the atomic orbitals and they formed the molecule. So when you see the energy profile diagram here they are possessing the highest energy, and energy gradually decreases when the hydrogen atoms are coming closer to each other, and finally it reaches the minimum value and again starts increasing. This minimum value, this energy loss, that means hydrogen atoms are separately when they are present, they are having the highest energy. When they are coming closer to each other, attractive forces dominate the repulsive forces. When they come the least possible distance, then they lose the last of amount of energy, so that their potential energy increases, and obviously the amount of the energy that they are going to lose in this process is 435.8 kilojoules per mole. And afterwards again repulsive forces starts increasing, and the minimum distance that they can come closer to each other is 74 picometers. That means lesser than this distance both of these hydrogen atoms cannot approach each other. The reason is, if they try to come even closer to each other, the nucleus present in one hydrogen atom try to repel the nucleus of the another hydrogen atom, so that repulsive forces between the nucleus will raise the energy. So in this category, this is the distance at what the minimum distance they can approach is 74 picometers. So this can be considered as the bond length. So that whenever hydrogen atoms, when we take the two hydrogen atoms in the gaseous state, and when they form the H2 molecule, the amount of energy they lose is 435.8 kilojoules per mole. And if the same amount of energy if we provide to the H2 molecule, it will break the H2 molecule into its respective hydrogen atoms. So that's why it is called the bond dissociation enthalpy or bond formation enthalpy. And what type of forces exist at this particular point? At 74 picometers of the distance in the H2 molecule, the attractive forces becomes equals to the repulsive forces. So this we can consider as the equilibrium distance, that is 74 picometers. After this equilibrium point, if you come left side, then repulsive forces between the electrons as well as the nucleus will start operating. That will cause of the increasing of the energy, and above that side attractive forces dominate the repulsive forces, but exactly at this point both attractive forces are equals to the repulsive forces. So in this way we can discuss the formation of a molecule. So during the formation of any molecule from its respective atoms, whenever a bond is formed by the overlapping of atomic orbitals, there shall be some loss of the energy. That loss of energy gives the stability to the molecule. And overlapping concept we already discussed in our previous classes. Please do watch that video. Thank you one and all.